Hello, everyone. Come on in. Got more people filtering in as we speak. Can y'all hear me? Chloe, can you hear me? Daniel, can you hear me? Hello.
Yeah, I can hear you.
Okay, that's cool. And Chloe, you can hear me as well? Y'all happen to be the faces I saw, so even if you didn't talk, I know you can say yes or no. Let me get something set up right here real quick. That's not good. Let's see what this is. Still not good. Still waiting for people to get in, and I'm also trying to set up my notes page here. So I have to give everybody a few more minutes and then we'll get started. Okay, this is working not as well as I'd like, but it's working. Anybody have any questions while we're here? Just go ahead and blurt them out. Generally, that's the way I allow people to ask questions. You can do the little hold your hand up thing that Zoom offers, but you can also just speak up. If it gets too messy sounding or too, I don't know, distracting, then we'll employ some other means. But right now, it shouldn't be a problem. So go for it. Still working here. Sorry about the time. Now we're about 5 students short. Hoping to give them a couple more minutes since I was late. I mean, of course, I sent y'all your link at like 10 minutes till class was supposed to start. So obviously, I feel a little bit obligated to give them some time. No one have any questions? If you can't speak, like you don't have audio, feel free to type it in the chat. I have that there as well. So, all right, looks like this is ready to go. And this date is going to be,
I had a question about the Pearson
yes.
link.
Uh-huh.
Um, I tried getting to it via Canvas, and it says contact you, and it says for students to access your Pearson course, you need to finish linking it with your LMS course.
Yes.
Okay.
So I did that this morning, but sometimes it takes a couple hours. I would hope it's probably ready by now, but if you've already tried it, you might have to first empty your cache.
Oh,
So
okay. Okay.
give that a try and then go back, and it might help, hopefully.
Okay.
Okay, now let's see. Today is the 13th, so we got that. All right, looks like we're ready to roll now. And I've got enough, I suppose. Will every Zoom meeting be recorded for us to watch later? Yes, I do copy or immediately after this, I render it in the appropriate file format and then I post it on my YouTube channel. So that's where you'll find it. Uh, I don't necessarily put a link to it in our module, but sometimes I do. I don't know what I'm going to do this semester, but it definitely will be on my YouTube channel. What I recommend is go to my YouTube channel and go ahead and subscribe. And then every time I post something, you automatically get an email notification that I posted it. That would save you some headache and also might save your behind in that you could, in principle, otherwise just miss something that I decided to do at the last minute to show you how to do a certain problem, and then like maybe the next day's a test. So anybody that actually had that, they would know that I sent it. They'd go and watch it, and they might have an advantage over you on the test. So I do recommend you subscribe, but then you can just unsubscribe later. I don't do too terribly much. I'm not making any money or anything like that off of it. So it's not that I'm trying to do that, but yes, if you subscribe, that'd probably be the best bet. Anything else? All right. Well, we've got a pretty good number of students. We've got 10. Our enrollment's supposed to be a little higher than that, but that's okay. This is the Physics 241 section N02B. It's actually, I kind of got mixed up and made my syllabuses a little mixed up because I thought I had, with this class, I thought I had a regular internet lab, but it turns out that my other internet class, I had an internet lab. So if you see something funny in the syllabus, it might be a leftover problem where I had to convert those at the last minute. So by all means, let me know. The syllabus is up there. The very last page of it is something that you're supposed to actually fill out and then turn in to me. I'm going to put in a turn in link right there on the module one, and you can just upload it as a PDF. I only accept PDFs to be turned in to me through computer. So make sure you always convert your stuff to a PDF. That's the same way where our labs are going to be done. So I'll talk about that as well later. I'm not going over the syllabus tonight because what I plan on doing is making one video for the syllabus, and I was hoping to have it done by today, but yesterday I had some problems rendering the files, so I had to redo it. So I should be able to do it tomorrow, and when I post that, I'll let everybody know. I probably will put a link to that one, either in the helpful links and documents module or in week one module, but probably the helpful documents and links module. Has everybody seen what we have in Canvas right now? Anybody not see it? Feel free to chat that if you wish. Okay, one thing I have to go ahead and let everybody know is these videos will be posted to my YouTube channel. Anybody can actually view those. I I'm not sure. It sometimes shows the little names down the side. So you guys can feel free to put, first initial, last name uh, as your name for your Zoom user interface. So it won't show, for instance, on the internet. The big problem being, obviously, you guys might be, I don't know, in witness protection program, for instance. And it would be a real bummer if you escape from, let's say, the mob, and then all of a sudden, because Mr. Younger put his video up on the class, uh, somebody found you. That would be a problem. So, what I need you to do is, if anybody has any objections to their name or they're occasionally me mentioning their name, I will never mention your whole name. I might mention your first name or something like that. I'm never going to mention your whole name. But if you have a problem with any of that being seen, I want you, one, to go ahead and change your username for Zoom to just something innocuous, like just your first name, or maybe your first initial last name or something like that. And what I'm going to do each day we have class is I'm going to ask you all to chat me your first and last name because that shouldn't pop up on the video at all. So if you chat me your first and last name, I'll have that as your role. I've got to look into that a little bit too. I want to make sure that there's no way for you guys to get access to that chat because if you did, obviously that would sort of defeat the point of me trying to hide your names. But if anybody has specific objections to their name even appearing here, or their face appearing here, make sure you send me an email and let me know. You don't have to give me any details. It's none of my business. But if you have a problem with that, maybe you're what was that movie? sleeping with the enemy. Maybe you're sleeping with the enemy and you're trying to run from somebody. That would be, this would be a bad place to catch you. So just let me know if y'all have any problem like that. I'll do what I can to make sure you're not posted that way. And feel free just to use random stuff like that. I believe even if I don't do the chat, there's still another way for me to figure out the role. So I'm going to check and make sure that the actual chat doesn't appear on my YouTube channel and there's no way to actually get it. So I'll double check that. Or if anybody finds it when you're actually looking on my YouTube channel, feel free to let me know. I'm going to go ahead and type that here. It's on my syllabus, so you probably already know it, but it's www.youtube.com/Billy Younger Physics Solutions. So if you'll notice, it's youtube.com/Billy Younger Physics Solutions. The B in Billy, the Y in Younger, the P that begins physics, and the capital S, or excuse me, the S that starts solutions. All of those are capitalized. And hopefully that'll help you find it. You'll see my cute little chihuahua with a highly photoshopped photo, not well photoshopped, but a photoshopped photo of him. And you also see my minion that I made out of a pumpkin. So you can check that out. What I wanted to go over right now is I'm going to go ahead and share my screen. And first I'm going to put my screen on a page that's remotely helpful. Okay, now I'm there. So I'm going to go ahead and share my screen real quick. Waiting, waiting. Okay, there it is. So right now you're seeing our Canvas page. This is the operating system or the software that we're using right here. Not unlike Facebook or Instagram or something like that, is a program called Canvas. Other ones that other schools use are things like Blackboard or Moodle. At UC Berkeley, they make their own, and it's called B-Space for Berkeley Space. This one's called Canvas. The generic stuff that the college demands of me is in this TCC student information, and that was the only module. That's what this thing here is called. That was the only module that was available to me first thing this morning. So that's why I stuck my syllabus there. Now that the other modules are there, I'm going to put the syllabus where it goes. So you should go to helpful documents and links. And here you first want to watch the quick video on your syllabus so you can learn a little bit about the importance of a syllabus. And it looks like I'd already moved it here. I don't know how I ended up twice with it. Oh, I see if that was the wrong one. I'll unpublish that. Oh, by the way, there was a PHY 241D01B. That was a syllabus that was posted here. I don't know how it ended up here. I must have sent it to the wrong place. But this one, the NO2B L02B, that is your syllabus. So if you have that other one, throw it away and then download this one. Uh, it's in PDF format. That way everybody can open it. I have the Word version, but obviously I don't just give that out because that's an easy way for someone to make up a fake version of my syllabus and get me in trouble. So it's here. The other things I wanted you to notice, all these things that don't have checks, you can't see from your side. So you're not going to see anything but these first three things until you get way down to here. And this is where the Zoom invitation is that I just sent you via email. This is where the old ones were from the previous semester, so I'm just erasing them as we go. Uh, if you go down a little further, you'll see this is your allowed equation sheet. You'll notice this is actually the Physics 241 equation sheet for the entire semester. So it has not only not only equations from the first and second chapter, which our first online test will be on, but it has all the way up through chapter 15. That's what you'll have access to every test, your online test, your face-to-face test, and your final exam. You'll also have access to this, which is a copy of the periodic table. This is an inside cover of Giancolli's fourth edition textbook. This is the second page of that inside cover, and this is the back page of that inside cover. These things have all the constants that we use for instance, gravitational acceleration, stuff like that. It also has all the SI prefixes, and it also has their values. In other words, what does a milli correspond to? What does a micro correspond to? It also has conversion factors, stuff like that. And then there's also a moment of inertia uh, page here that later on we'll need to know the moments of inertia to solve certain physics problems, so they'll be there as well. Uh, they're not normally given out on tests until we get to the chapter that covers rotational motion. Right here is something that says Physics 241, 242 course grades. That is a spreadsheet you're supposed to be able to download, and it'll allow you to keep up with your own grade by you typing in your grades. I need to adjust that a little bit because I changed this a little bit. When I do that, which it should be done by next time, I'll let you know and you can download it. We will have a grade book in Canvas, and you can see that. Uh, However, sometimes it will be further off than this one will. So that's why I like you guys to have access to that. The way we calculate our grade in this course is called a weighted average, and that's something anybody that's thinking about majoring in any science or engineering needs to learn how to do. It's the way we calculate, for instance, your GPA. In the case of your GPA, what you do is you represent an A as a 4.0, a B as a 3.0, a C as a 2.0, a D as a 1.0, and a F as a zero point 0.0. And then, of course, if you're at a school that has plus or minus, they have other things that they consider a A minus, a A plus, and that kind of stuff. But we just have the 1, 2, 3, 4. Uh, if you wanted to calculate your GPA, what you do is you take your grade for each course. Let's say you got an A in a 3 credit hour course, then what you want to do is take that 4.0 for the A and multiply it by the 3.0 for the credit hours. And then you do that for all the other courses as well. And when you're done with those multiplication problems, you take those results and you add them up, and then you divide it by the total number of credit hours that you have at that point, and that'll give you your GPA. When you're doing a grade, it's the same thing, except you take the grade you got on a particular assignment, you multiply it by the percent that particular assignment's worth, and then you do it for the next assignment and the next assignment and the next assignment. And when you're finished putting all the assignments you've had, you then divide it by the sum of all the percentages you used, and that is a weighted average. But this does that calculation for you. I can show you without doing it in words. Obviously, if you guys want to learn how to do it, just let me know. I'll do what I can to help you. There is the thing here that's kind of useless. It says Canvas will not open a YouTube link. What should I do? So I do that on purpose because it's kind of funny because you go on here and it's got a Canvas link. So so you literally can't look at it. But let me show you what happens. If I click on this, what'll happen is I get that sad face. Okay. Whenever you click on a link in Canvas and you get the sad face, what you got to do to fix that is you go up here and you see that little arrow, that little window with the arrow sticking out the side of it. You could click there, or you probably can click here as well. But I always just tell students to click right on this, and now you'll see, up, we're at Mr. Younger's YouTube channel. I don't know why this big thing over here is here, but there's my Cosmo. That's one of my Chihuahuas. He seems to be smoking a hand-rolled cigarette. There's the physics solutions. By the way, if you want to do a search for something in my page, you want to type it in right here, not up here. That's just a search of YouTube. This is the search of a particular channel that you're on. So that's where you want to do that. But that's how you deal with when the window does not open. So let me go ahead and kill that. So when this window comes up like that, you just click there. It might even work over here. Let's see. Yep, it did. So either one of those are fine, but that's what happens when you click on a link from Canvas, and you obviously don't want that to happen. So I'm going to go back to the modules. Looks like a couple more people came in. Uh, let's do that over here. And I also got to open up the chat in case anybody chats while I'm talking. All right, so I got this. Now, what I wanted to show you here, this is the generic stuff, like I said, that TCC uses. We don't really need too much of that, but obviously there's some things that are helpful, like if you need Zoom support or Canvas orientation or Canvas support, if you need help with Respondus Monitor and Lockdown Browser, if you need to find out where to purchase your course materials, that's another thing. I'm going to advise you that the cheapest way, if you want to be the absolute cheapest, or if you want to spend the absolute smallest amount of money to get what you need for this course, then what you will do is follow my advice. The advice would be you go down to week one module once it works. Of course, I'm going to hopefully it'll work by the time I get here, but I'm going to close this window for right now. And notice this is interesting science related links and documents. So these are just things that I've found helpful over my lifetime, as well as certain videos that are interesting. Richard Feynman, this is a wonderful talk by one of the people that worked at Los Alamos and a Nobel Prize winner. Here's J. Robert Oppenheimer interview. So in case you recently saw the movie Oppenheimer, that'll help you. This is one of the main books that movie was based on, American Prometheus. Here's the audio book. Making of the Atomic Bomb is another book that was based on. So there it is. Uh, these are some different. This is a MIT course on neurology by Nancy Wisher. She's literally a woman that discovered a part of the brain that no one had seen before, and because of that, she got a kick butt job at MIT. So that's awesome. These are two psychology related books that I found infinitely helpful in light of my ability to deal with stresses and anxiety attacks and stuff like that. So, highly recommend you read those if you're having any psychological problems like panic attacks or OCD or trauma, stress, PTSD, that kind of stuff. They're just really wonderful books. Here's my open interests, things I read about. I have, and it's basically a list of some of the books I've read in various areas. So you see a lot of stuff on the Arab Israel conflict, also as well as Russian history stuff. But that's just stuff that I'm interested in. Totally, in case you're interested on, I don't know, educating yourself beyond physics. This chapter practice is completely optional, but it's like if you're preparing for, say, a test and you find that the test, which is going to cover, like 4 or 5 chapters, you find that you're really just having problems with chapter four. 1 through 5 isn't a problem except for chapter four. Then what you want to do is come back here and go to chapter four and do this over and over and over again. I have to check them to make sure they're all working. Every time I make a new one, it sometimes leaves out questions, so I got to check them. They're all here now. Tomorrow, I'll be checking them to make sure they're all right. I'll start with chapters one and two because that's what we're doing. Down here, this will be where all your practice tests are. As I mentioned in the syllabus, these are optional, but there's a wonderful amount of extra credit you get if you do them. So I recommend you do them. Plus, they're extremely helpful in doing the tests. Here's where your online test will be. You can see sort of how they play out. None of these are available yet, but that's where they will be. This is where your face-to-face test will be. There won't be that many. These are various ones I've used over the years. I got to get rid of them, but this is where your face-to-face test will be when they occur. So this is where I'm going week one. Notice the date's wrong. That's because I just copied it over this morning. All of these with the little chain links, they are all links to videos on my YouTube channel. Okay. Uh, all of these with a little book and things, those are what we call assignment links. So you could actually click on those to go to assignments. For instance, when you do your lab, the first lab we're going to do is intro to lab. You do that document, and then you go to turn it in. You're going to turn it in right here. Okay, and the syllabus as well as this little part tells you exactly how what you have to do to turn it in and all that good stuff. So let's try showing you what happens, and hopefully they're working on it now. The Pearson site's hopefully working now. I'm going to click on it and see. So chapter one, conceptual. So this is supposed to happen. Let's see what's next. Oh, great. This is not looking good so far. My lab and mastering. Yep, it's still not ready yet. This should be fixed by sometime tonight, hopefully. Let me check right now, see if there's anything I can do. I'm gonna kill that for starters by closing that window and going back to here. Okay, and now I'm gonna go to Access Pearson, open Pearson, see if this works. Open that, see if that works. Okay, this is looking a little more promising. Okay, so this is the part that's supposed to take an hour. I did this morning, and evidently it didn't work, so I got to do it again. So I'm going to do this. Yes, copy this course, and uh, new courses may require a short time to create. So it's going to pop up, and then the dates will be wrong, and I got to go in and fix it. But I suspect it's 5:45 right now. I would bet this is going to be done by the time class is over, which is 6:40, but it might not be. But if not, at the worst, I think it's probably be done by 7:45. So y'all can check that out and keep checking that out. Like I said, when you do it, if you go on here and get this, you might have to go up and empty your cache in the settings. And when you do that, you pull this open and you just type in cache, and right here is where you delete your cache, and then you try going back in and it'll work. Okay. I don't really need this right now, so I'm killing it. I got two people in the waiting room. Admit all. Okay. So let me kill this window now. That's done. That's done. Now I'm here. Okay. So the main thing that I wanted to show you was the Canvas site and how we use it and what we use. Uh, There are announcements. I usually only use those a couple times a semester, and they get emailed to you. The main thing you'll do normally when you come here is you'll go to modules, and that's where I'll have a weekly module that tells you what you are responsible for that semester or that week. So these dates aren't right. In fact, you are a Monday, Wednesday class, and that means these homeworks are supposed to be due at 11:59 p.m. on Sunday. That would be 6 days from today. Today's the 13th, so on the 19th, all four of these will be due. Not only that, you get a free 2 week trial, so there's no reason for you to miss them. It doesn't matter at all. If you do them late, you're going to have points taken off. So make sure you get them done and get in the hang of turning them in on time. For instance, we don't have class Monday because of Martin Luther King Day. Uh, Still, I'm very hesitant to set this back to the following Sunday because I really want you guys to get into the swing of turning things in by 11:59 on Sunday. So I'm going to leave it as due 11:59 on Sunday, and we'll revisit that. If we have any problems with someone getting it done, maybe I'll push them back to the following week, just or at least the following day, since we're allowed an extra day. Maybe I'll put them till Tuesday. At 11:59 p.m. for that first set of assignments. But from now on, it's always going to be Sunday at 11:59 p.m. Uh, Significant digits, that's a video where I showed you that significant digits are not really what real scientists use. We use something called propagation of error. We're going to have a lab on that later, and I'll teach you about it. We will use them though throughout the lab because they're a lot easier way of doing things. So here's the significant digit rules that I employ. Here's a video teaching you how to read vernier calipers, which we'll learn how to use later in lab. Here's an intro to lab, the first lab that we're doing. And then here's some parts to that for the online lab in general, but you won't use it since you have a face-to-face lab that'll be meeting. Let's see what else is here. This is where our extra credit will be. And in fact, I did already post one extra credit. This one, I'm going to go in here, edit. Notice it says PDF. So the way you're supposed to turn in things, as you'll read in the syllabus about my labs, but in the case of extra credits, this is something where you're supposed to do some unit conversions and show me your work. So just do them by hand as neatly as possible. Take your phone, take a photograph of it, convert that photograph to a PDF, and then turn that in here. That's everything that you turn into me through one of these electronic portals should be turned in as a PDF. So make sure you guys do that. I'm going to clear the date and then I'm going to set the date to the 19th at 11:59 p.m. Labs won't be like that though. For instance, if your lab meets on Wednesday at 9 a.m., then that means your lab will be due the following Wednesday at 9 a.m. Okay, so keep that in mind. I'm going to go ahead and hit save here. Now we know that extra credit's there. Uh, Now, if the Pearson site was really working, it'd be really great because I could just click right here and then open up the textbook. I don't think it's going to let me do that, but let's see. Okay, I know I can do it this way. Let's see if that works. Ha, it might be working already. Yes, it is. Good. So yeah, I do suspect your homework links will be correct pretty soon. What I'm going to do is open textbook and just show you what we're going to be doing. So chapter 17 obviously is not it. That's what I'm doing in my 242 class, which is the last thing I taught. That's why it's showing that. We are doing this chapter. Chapter 1, Introduction, Measurement, and Estimating. So I'm showing you this specifically so you'll know exactly what stuff we're supposed to cover, and I can sort of talk you through it. I'm going to increase the size here a little bit so make it a little better for us. But we use in the physics community, we generally use what's called the System International, which is the System International, blah, blah, blah. I'm trying to do a French accent. That was not a good job. But anyways, uh, anybody have any idea what the System International is or another name for that? Ah, Daniel just asked me that is this supposed to be an online lab? Now there it might be some truth to that. Let's see. I'm checking something real quick. Oh yeah. Yep. That is right. Yeah. Remember you might not have been here earlier when you asked when I was saying this, Daniel. But yes, and the metric system's the right answer on that, John. Uh But yeah, I told my students that I got a little mixed up about that. You're absolutely right. This lab is a online lab. I plan on making the video tomorrow at noon for that. I was thinking it was my 242 lab that was that, but I'll be making this one tomorrow, and we will be doing intro to lab. And there's an addendum to it that helps it be able to be done at home. So keep an eye out for that video when it's posted. But that video will be I will put that link here because there's no way you'd even know it exists if it wasn't for me putting it in the module. So when I make the video that introduces you to Lab 1, then you will have the opportunity to do that Lab 1. Uh, that should be done tomorrow at noon. And I tried to do it at noon because some people have a lunch break. So if you actually wanted to attend that Zoom session, I'll be doing it as a Zoom session. You're welcome to attend. The other invitation will be in that same place where the first invitation is. So you can click in on it, but you're not required to at all. Okay, I just tried to make it at a time where people could attend. Thank you for asking me that question. It made me look back up and see whether or not I was right. So yes, we are doing an online lab here. Uh, the standards of units for scientists. Yes, that's right. But I had a couple people, Eric and John, did give me the right answers. The System International is another word for the metric system. The metric system, sort of the old name. And anybody have any idea why it would have been in French? Why are they calling it the System International and not the International System by, you know, Thomas Jefferson or the International System by, Barack Obama and I don't know, Donald Trump? Anybody? So it's kind of a neat historical perspective that I'm trying to show you here. Specifically, uh, the planet was a bit of a mess at the time when, let's say, Thomas Jefferson was the ambassador plenipotentiary in Great and I think he was in France at the time, and he actually lived in France at the time when the French Revolution broke out. So, like, Thomas Jefferson literally saw wealthy people ripped out of their mansions and their castles and their stages and stuff like that, ripped out and then ripped to shreds. It was really a horrible thing. But what that spawned was Napoleon. The ditch didn't necessarily turn out to be the greatest thing, but one of the things that was done was we had just went through the Renaissance, and then we're actually experiencing the Enlightenment. That's sort of how America came to be, was through this Enlightenment process where people were trying to make things the best they could be using our brain power to figure out stuff. So that's why we had stuff like John Locke and all these people. We started reading them again, various other people from the Revolution. But the main thing is France was a superpower at the time. So at that time, they tried to come up with a unit system that we could use where the whole planet would agree to it. And since they were the superpower, they took the reins in that, and hopefully that just reminds you roughly the time period. Is this about the time that Thomas Jefferson was president, or actually in that case he was actually ambassador, so it was just before he became president. And in that process, they made a rational set of units. Specifically, we had a sort of higgly-piggly type of units before it where basically it was just a historical litany of facts that we were using. So, for instance, we had came up with the idea of a pint, which was useful for, serving beer in Great Britain or something like that. But then later we wanted something bigger, so we said, well, let's say take 2 pints and we'll call that a quart. And okay, everybody said, okay, well, we'll define the quart to be 2 pints. And like, okay. And then we had a cup, and that was going to be half a pint, and therefore 2 cups equals a pint. But then how many quarts is in this new thing called a gallon? Well, there's going to be four of those, and you get that big G that you might have seen in grade school. It's a big G with four Q's in it, and then inside of each of the Q's is two P's, and then inside of each of the P's is two C's, and then inside each of the C is eight O's for ounces. And using that, you could basically figure out, how many cups there were in a gallon, how many ounces there were in a gallon, how many pints, how many quarts. But it was really just ugly, and it was based on, basically the history of the units. So we had conversion factors, like weird things like a factor of two in one case, a factor of four in the other case. So for instance, 1 quart is, or excuse me, 1 gallon is 4 quarts, whereas 1 quart is 2 pints, and 2 pints could be 2 or 4, or 1 pint could be 2 or 4 cups. They ended up making it 2 cups, so on and so forth. So that stuff was a historical system of units. What Napoleon and the other people of France had an idea for, as well as other nations, was the idea that every unit should differ by another by a factor of 10. So you'd have like a base unit, and then 10 times bigger, there'd be a prefix you could put in it, and that would represent 10 times bigger. There'd be a different prefix that you'd put in front of it when it's 100 times bigger, and a different prefix when it's 1,000 times bigger. And then you could do the same thing on the small side, where it'd be a different prefix for 1/10 and a different prefix for 2/10, or excuse me, 1/100th, and then a different prefix for 1/1000th, and so on and so forth. So that's where the System International came in, and it is a rational system. We don't have to look up or remember some weird G-man thing to figure out stuff. So that's what this chapter is about: is introducing us to that system of units and how it works, and telling us some things about how you work with numbers, how you can convert them back and forth, and also how you can do what we call in the physics community Fermi, Fermi. That's an Italian name. If you've ever heard of Fermi Lab, that or Fermi Lab is what a lot of people call it, but it should be technically Fermi. But that's by Enrico Fermi, who was, in some sense, the huge brain behind the Manhattan Project. In addition to it being J. Robert Oppenheimer and all the brilliant people he had working for him, he had Hans Bethe, who won a Nobel Prize. He had Richard Feynman. He was the guy that you kept seeing in the movie playing the bongo drums. He's a Nobel laureate. I think at one point, in fact, he bragged, our General Groves bragged that he had six Nobel laureates in their shirt sleeves eating bologna sandwiches at a picnic table, and Oppenheimer was bossing them. So that gives you some idea of how brilliant the people were working there. Niels Bohr came. He had to act like a different person though, obviously using a pseudonym instead of his real name. But he was there. So all the that Manhattan Project stuff. We have from that, this guy Enrico Fermi was sort of the person that was doing the experimental work because the actual project, the Manhattan Project, was mostly an engineering problem. The physics was pretty well worked out. A guy by the name of Robert Serber came in as an underling of J. Robert Oppenheimer, and he gave everybody an introduction to the physics of making a nuclear bomb. And that's been declassified. You can download it and watch it all you want, or download it and read it all you want, work out the physics yourself. It's really pretty straightforward. That's really the physics that you need to create a nuclear weapon. That being said, there's a monumental engineering wall to overcome before you can actually make the weapon, and that's what they were doing. But at the same time, you still needed some experimental backup, and that's what Enrico Fermi was doing. Enrico Fermi had worked under Mussolini, and in fact had gotten so awesome that he built a huge, awesome physics department in Italy, and he ended up winning a Nobel Prize. And of course, Mussolini wanted to show the world how his system, which was, also ultimately fascism, he wanted to show how his system was superior to everybody else's. So he really wanted Enrico Fermi to go and collect his Nobel Prize. And Enrico Fermi said, "Okay, well, I just want to take my family." And he said, "No, I can't let you do that." And he said, "Well, then, no, I'm not going." So sure enough, Mussolini caved, allows Enrico Fermi to take the trip to Sweden to get his Nobel Prize, and Enrico Fermi immediately defected to the United States, and with his family, of course, and then ultimately was one of the big brains that allowed us to create the nuclear weapon. And he did that at University of Chicago. He in fact made the first, they called it a pile, Pile, but basically it was a sustained nuclear reaction that they could control, and it was done under the football stadium at University of Chicago. So he was sort of doing that side, and he was working out all the details, trying to find out, how big is the nucleus of hydrogen? How big is the nucleus of helium? How big is the nucleus of beryllium? How about carbon? How about boron? How about lithium? How about nitrogen? All that stuff he was just doing, bam, 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 going through it. And then he would come and meet with Oppenheimer every now and then, as would Niels Bohr. Einstein met with Oppenheimer, but not during the Manhattan Project, or not at the Manhattan Project, that sort of thing. So that's why we're learning all this cool stuff. And Enrico Fermi, like I said, those are the Fermi calculations. He's the guy that lifts up some little blades of grass or something like that when they're testing the Trinity bomb, and you see these blades of grass moving. The reason why Enrico Fermi did that was specifically he knew that he could estimate the size of the nuclear explosion that happened from the Trinity bomb, because he knew how far away he was, and he could use the definition of work, which equals the integral of P dV. And from that, seeing those particles of grass that he dropped, seeing how much they moved like that, that could tell him exactly how big that weapon was. And in fact, he came within a few percent of the actual calculations, or the actual measurements that were done, just by his quick back of the envelope calculation. So that's why we call them Fermi calculations. But there's stuff like you look at a room and you say, how many fruit flies could fit in that room? Or like I've seen on Instagram and TikTok and stuff like that. I saw one time someone took and filled a shower stall up with Fruit Loops. And it was really sad because they filled it up and they ran out of Fruit Loops. They had to go to the store. They get some more Fruit Loops and they ran out again. They had to go back to the store. And I'm like, it would have taken 2 seconds to do the calculation and you wouldn't have had to go back to the store. That's a very typical calculation. And that's what I mean. You need to be able to do quick calculations like that. You'll see some other ones when you start taking the practice tests. This book uses some ones like how many times what do you expect a human's heart to beat in their entire lifetime? So that requires you to estimate how long a human's going to live. It requires you to estimate how long or how many beats per second the heart beats and stuff like that. And that presents a nice calculation. Or how many pennies will fit in a shoebox? Or if you stacked dollar bills on top of each other, how high would $1 million be? That kind of thing. So those are all what we call sort of back of the envelope Fermi calculations, stuff like that. If you look over at ODU, for instance, they have a professor over there that's written some books on this stuff. They're called Guesstimation, Guestimation. He's the chair of the physics department at ODU, and he's written like two or three versions of that. But that's a great book on just learning how to do those quick calculations. So that's one of the things we're going to learn as well. You can see it talks about how science works. It differentiates between models, theories, and laws, measurement and uncertainty, and significant figures. Your book's going to make some very specific claims, and what you got to remember is when you go to take your online test and your face-to-face test and your final exam, that those tests are made from the banks that this author made. So you need to answer questions like this author would answer it. So one of the things I teach my students in my lab, for instance, is the number 500, 500. As written, 500, it only has one sig fig because the rules for sig figs for me are the leftmost non-zero digit is the what we call the most significant digit, or MSD. So if you look at the number 500, the leftmost digit that's not zero is the 5. You could put 0500 and it'd still be 500, or you could put 00500, that'd still be 500. But the main thing is the leftmost non-zero digit is called the most significant digit. And since it's called the most significant digit, that probably tells you it's significant. Uh, the rightmost digit that is non-zero, if there's no decimal present, the rightmost non-zero digit is called the LSD, the least significant digit. So in the number 500, there's no decimal present, so the rightmost non-zero digit is also the 5. So the MSD and the LSD for 500 is the 5. Therefore, it has one sig fig because the rule says the least significant digit, the most significant digit, and all the digits in between are significant digits. In this case, it was just one, so it's one sig fig. Now, if you do it as 500 with a period, a decimal at the end of the 500, so 500 decimal, in that case, the first rule says the leftmost non-zero digit is the most significant, so that's the 5 again. And then you say if there is no decimal present, the rightmost non-zero digit is least significant. In this case, there is a decimal present, so we skip that. But if there is a decimal present, then the rightmost digit, period, the rightmost digit is the least significant digit. So in this case, the 0 to the left of the period is the LSD. So in 500 with a dot after it, the 5 is the MSD, the 0 next to the decimal is the LSD, and the MSD, the LSD, and everything between is a sig fig. So we have three sig figs in that case. So 500 with a decimal after it is three sig figs. 500 with no decimal is one sig fig. That's the way I do it in my lab. In this book, Giancoli argues that this is exactly ambiguous. So that would be the answer you'd say if he asks you how many sig figs are in 1500, you'd say ambiguous. Or how many sig figs are in 300? Ambiguous. Or how many sig figs are in 1 million? Ambiguous, right? Whereas in my case, you'd have either one or six or seven or something like that. Okay. Any questions on that one? That's kind of important. It's not that important in that it's not going to cost you many points, but it's important in the sense that why would you miss a test question if it pops up if I've literally told you not to miss it? Okay. Uh, the French city that was the center of the scientific thought. Yes, Eric mentioned about the French city being Paris and stuff of that being the center of scientific thought. And in fact, yes, that was the case. And Thomas Jefferson, in fact, loved Paris and France. He said any educated man loves to be in quote unquote France and specifically Paris. So yeah, that's kind of cool. I'm a big Thomas Jefferson fan too, by the way. Despite obviously he's not a perfect person. Nobody from the slavery era is perfect, obviously. But anyways, that's I listen to Thomas Jefferson Hour and all that good stuff. So all right, now that I've gotten through that part, we also are going to go to unit standards in the SI system. We're going to go through converting units, order of magnitude, rapid estimating. That's the Fermi calculations I'm talking about, and dimensions and dimensional analysis. So now that I've shown you all this stuff, what I really want to do is go ahead and show you something different. I'm going to go back to the modules, and I'm going to stop sharing my screen, and I'm going to pull out my good notes on my iPad, and I'm going to walk you through some stuff. Okay. So what I'm going to do now is I'm going to say share and advanced. I'm going to say iPhone, iPad slash AirPlay. Now I have to open up my side, and that should pop up in a second. Okay. So you're now looking at what's on my iPad, and you see each of the pages has my YouTube URL on it, so you can find that. What we want to start off with is talking about this SI system. So I'm going to give you a hint. So for starters, I'm going to tell you a little bit about myself. I am a late bloomer. I enjoyed my life thoroughly up through probably 10th, 11th grade. In other words, I did everything but what I should have been doing. I was just having a really good time. Rode bikes and half pipes and quarter pipes and stuff like that, and skate parks. And I had a penchant for, dating, that kind of thing. That was all I really cared too much about. And I didn't put hardly any work into school. In fact, I can remember in my entire uh, kindergarten, elementary school, middle school, and high school career, I remember doing homework like two, three times at most. And that's because I literally only did homework two or three times at most. So I was really a deadbeat student. I graduated by my own estimate, third from last in a class of 60 at Currituck County High School. So I was really a deadbeat. I went to a community college like you guys are now. Not because I was being smart and saving money, but because I would not have been allowed anywhere else because I had done so badly. In fact, I'd done so bad, 2 weeks into my senior year, my advisor calls me in and says, "What are you planning on doing after school?" And I told him. He said, "No, you're not." I was like, "What?" He said, "You don't have enough math. You're short 3 math credits. You're not going to graduate." And he immediately switched me from my enrollment that I had to taking 3 classes my senior year. And that turned out to work out really well because all of a sudden I got interested in math and started doing well. So I'm giving you that just to tell you and to warn you that I am chronically hung in somewhere between third and sixth grade. So all of my humor is like a third grade to a seventh grade boy. Okay. So I apologize up front. It might make you laugh a little bit, but let me show you the first case. So I've come up with a mnemonic for helping you with the SI system. So if I can find my glasses, which are not on my forehead, the SI system has a system. It is a system of, ooh, I got to change colors on that. The SI system is a system of base units like the meter, the this is weird. Technically, it should be the gram, but we use the kilogram in the SI. The second is the unit of time. And in fact, another name for the SI system is the MKS system. because it means meters, kilograms, and seconds. So that's a base unit. So it's the SI is based on base units and prefixes. The prefixes act as multipliers of powers of 10. So I feel like that should be like two X's and three S's or something in that. But anyways, so my mnemonic that I use is the dot dot great dot dot monarch dot dot king Henry died. Notice that that prefix is actually a DA. And now I say by because this is the base. Drinking chocolate milk dot dot under. Notice this is a Greek mu, not a U really, but it looks like a U, so I'm treating it as a U. So the great monarch King Henry died by drinking chocolate milk under dot dot numerous dot dot. And here's where you see the wheels fall off and Mr. Younger's seventh grade brain comes in. For P, I came up with prostitutes. Okay. I'm sorry. Please, by all means, come up with a better one. I hope you come up with a better one and let me know it, and then I can start using it because my gutter brain keeps coming up with this. Now, the advantage of this is multifold. So, for instance, we can take a number like 0.0000000000123 dot 456 012. Okay, let's say that number is in giga. Let's say gigameters, and I would like to convert it to microns, also called micrometers. Okay, so here's the first use of this system. What I do is I will take and make a mark of this unit. So that unit right there is the gigameter. That means we're right here. Okay. Now what I want to do is count the moves or steps to 2 micrometers. So I'm going from here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I know in order for me to convert this .0000000000123.456 in order for me to convert that to micrometers, I've got to move the decimal 15 places. Not only that, I know that I got to move the decimal 15 places to the right. So I can do this as follows. I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right there is where I need to go, which is right after the 6. Okay. So now I can say my answer is 1, 2, 3, 456.012 micrometers, and that's the right answer. Okay. Now, that's a horribly, horribly, horribly inefficient way to do it. But if you were in a less it's mathematical science, like let's say introductory biology, which by the way, biology is now nowadays is quite mathematical too, but at least in the early parts, it's not too bad. This would work fine for that type of course, like your intro to biology. You can convert back and forth between these units all day long like this because you don't have to do it that often. Now, how do we do it in the physics world? Well, the first thing we remember is that I told you you start off with a base and then you go a power of 10 bigger. So we can call the base 10 to the 0, which of course is equal to 1. And then the deca, the dA here, is 10 to the 1. And this was 10 to the 0. Sorry, I meant to say 10 to the 0. But remember, anything other than 0 raised to the 0 power is 1. So anything other than 0 raised to the 0 power is 1. So that's 10 to the 0, that's 1 there. This one would be 10 to the 2, and kilo would be 10 to the 3, and that's what you expect. You know, kilo's 1,000. And then, of course, we've got dots. They're important, but we didn't find them important enough to give them names. So right here, we're going to say this one's 10 to the 6th because the first dot would have been 10 to the 4th, the second would be 10 to the 5th, and so on and so forth. Not only that, my 3, I don't like where it ended up, so I'm going to make that a little better so it don't look so bad. So there's 10 to the 3. This one's 10 to the 9, and this one's 10 to the 12th. So that's tera, giga, mega, kilo, hecto, deca. Deca is DEKA. And then base unit, deci, centi, milli, micro, nano, pico. Okay. So in this case, it's 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 6, 10 to the negative 7. And, oops, excuse me. I don't know why I said 6 and then just jumped to 7. That was obviously a brain fart. Okay. And there's my seventh grade humor again. I had to say the word fart. So 10 to the negative ninth, and then 10 to the negative 12th. Okay. Now, the reason I bring that up is we need to be able to do this more efficiently. So let's say I had, for instance, this was an example right here. Let's go to another example. Let's say I would like to convert 7.48 kilometers to millimeters. Okay. Well, it turns out that if you really want to convert units from one thing to the other, there's a certain class of units, I call them multiplicative units, that convert by you multiplying a number by something. Okay. These units would be units like mass for kilograms or grams, or time for seconds or minutes or hours, or length for meters. Those are all uh, units that are converted by multiplication. Units that aren't converted by multiplication, I bet you can think of some. Can anybody think of one where you have to use a formula to calculate or to convert from one system of units to the other? Aha, somebody's answered me. Yes, temperature. Specifically, if you go from Celsius to Fahrenheit, for instance, you have that 9/5, blah blah blah. We'll deal with that later. But yeah, that's an example. Another one's the decibel. So if you're looking for decibels, a decibel means decibel. So it literally means a tenth of a bell, and in fact, it involves a logarithm. So that's another one. But other than that, other than those two units, just about everything. Well, also conversions between Kelvin and Rankine, between Celsius and Kelvin, between Fahrenheit and Rankine. All of those are formulas as well. But again, that's all within the temperature realm. Everything else pretty much uses multiplication to convert them. And I'll tell you that numbers that have units, like the 7.48 kilometers here, that is called a denominate number. So let me just list that here. That's called a denominate number. Y'all hopefully can recognize the origins of that phrase denominate, just like a $5 bill is different than a $10 bill. They're called different denominations. So that's what that means. Okay. So the trick to converting units when you're using multiplicative units is if I have a number like 7.48 kilometers, if I multiply that by anything other than one, then I change its value, and I don't want to change its value. So to convert units multiplicatively, you have to multiply by one. So multiplicative are converted by, whoa, I wrote an M there, by multiplying by 1. The trick, though, is that 1 can be written a lot of different ways. You can write it as 1 over 1 because we know you can take any number and put it over 1 and it's still the same number. But you could also take the number 3 and divide it by 3 and that would work. Or you could take the number pi and divide it by pi, that would work. Or we could get even more abstract and do something like 12 inches is equal to 1 foot, or we could do 1 foot is equal to 12 inches. So that's our trick. We want to find an equivalent statement, something that makes two different denominate numbers equal to each other so that you can make a fraction out of it. Okay. So let's start off with 7.48 kilometers. And what I've noticed is students aren't necessarily that strong with fractions. The pandemic was not helpful in that scenario for even my best of my best students, which are the calculus-based physics students. So there's occasionally problems where students just have a hard time with fractions. So what I recommend is immediately take the number that you're going to convert and immediately put that over 1. If it's a number that has a unit like meters per second, then you'd put the meters in the top and you'd put 1 second in the bottom. But in this case, it just had a unit in the numerator. So then I want to set it up so that it can multiply. Now, what I'm going to do is from the table up here above, I'm going to make some equivalent statements. So from, or let's say not from the table, let's say from the mnemonic. It's a crazy spelling word. From the mnemonic, we know that 1 kilometer is equal to 10 to the third meters. That's what the 10 to the 3 on top means. But we also know that 1 meter is equal to, we wanted millimeters, so that's 10 to the negative third millimeters. So there's two equivalent statements that we can use. So what I'm going to do is write the number 1 in such a way that the units of kilometers cancels out. So what would I like? Do I want 1 kilometer on top and 10 to the third meters on bottom, or vice versa? Make sure y'all figure this out in your head, even if you're not typing out the answer. The trick is this is quizzing you to make sure you understand the material. So you should be able to come up with the answer. And then when I say it, you can check yourself. So we need to get rid of the kilometers. And what you should realize about denominate numbers is the number 7.48 is being multiplied by the unit of kilometers. So the kilometer sort of acts like an x, and the 7.48 sort of acts like a coefficient, so that you can realize, oh, if I have them like this and they're on opposite sides of the fraction bar with no adding and subtracting, then they can actually cancel out. So the right answer would be put the kilometer on the bottom. So I'll write 1 kilometer on the bottom, and I'll write 10 to the third meters on top. And the reason I can do that is now you see that this kilometer will cancel out with this kilometer, and now I'm up to meters. Now I need another fraction to take me to millimeters, so I'll put another fraction bar. Now, do we want the millimeter on the top or the bottom? Or vice versa, we could ask, do we want the meter on the top or bottom? So everybody try to think about it. Ah, gotcha. I see what you're saying, Eric. Yeah, in this case, because the unit that you have is actually in the numerator, you want that to be replaced with the unit of millimeter. So you're going to put the millimeter on top. But the other part of it is you also want the unit you have, which is on top, to be canceled out with the unit. So you need it to be on the opposite side. So we definitely need, since the unit in the numerator is now a meter, we definitely want the meter in the bottom and the millimeter on top. So I'm going to say, in this case, 1 meter on the top, and then 10 to the negative 3 meters, or excuse me, millimeters on the top. Beep, beep. Something happened there. Let's see. 10 to the third meters is 1 kilometer. That's right. 1 millimeter. Ooh, I said that backwards. Did I write it right? Oh, that's what happened. Notice this equivalent statement. I can't believe I did this. This equivalent statement was stated wrong. The way this is supposed to work is when you look at millimeter, the millimeter is 10 to the negative third meters. So I guess I just wasn't paying attention and wrote it in the wrong place. So that's the meter, and this is the millimeter. Okay. So now I can fix this. We did everything right, except I just had the equivalent statement written backwards and didn't notice until it's too late. So I still want the meter on the bottom, but this time it's 10 to the negative third meters and 1 millimeter. Now, something else I like, and you should consider it, is I use a different cancel out mark each time I do it. So that way, if I have a long string of them, I can always look back and figure out what the right answer is and figure out where any mistakes I made. Now, 10 to the negative third in the bottom is the same thing as 10 to the third in the top. So ultimately, we're going to be multiplying this 7.48 times 10 to the third and then times 10 to the third again. So that's times a million. So the answer, dang it, the answer is going to be 7.48 times 10 to the 6 millimeters. And that's the right answer. Any questions with that? Okay, we don't have a lot of time left, so I want to do a couple more. One, I'm going to start off with a really neat result. My mom used to tell me my mouth was running a mile a minute, so I'm going to start off with that. So let's write down 1 mile. This is another example. 1 mile divided by 1 minute. That's what she'd say. Your mouth is running a mile a minute. That meant, I'm a Gen Xer, so that meant get the heck out of my house, right? And that I was a pain, and that's why we spent a large part of our time outside. So what I'm going to do now is automatically have it over 1, and I want to convert that to miles per hour. The miles are already good, so I can leave that where it is. But the key thing here is I want to get rid of the minutes in the bottom. So what I know is that 1 minute is equal to 60 seconds. So I can write 1 minute on top and then 60 seconds on the bottom. And, oh, mile a minute, 1 minute is equal to, yep, 60 seconds. Oh, I wanted hours, stupid head. That's what's going on. I wanted in miles per hour. I don't know why I started putting in miles per minute or miles per second. That's pretty stupid. So I'm going to convert this to miles per hour. That's what I'm going for. So I'm going to write my fraction here. The mile, like I said, is fine, but I know, for instance, that 60 minutes is equal to 1 hour. That was what I was shooting for. Now you can see this minute cancels out with this minute, and I am left with, in fact, just 60 miles per hour. So if your mother, grandmother, or whatever's ever told you your mouth is running a mile a minute, you know that means it's been running at 60 miles per hour. Now, I want to convert another unit. By the way, I wanted you to also notice that's how you handle a unit when it's in the denominator as opposed to the numerator. You just make the unit that you want to cancel out with it in the numerator so it'll cancel the one in the denominator. So let's try another one. I'm going to go to a new page on this one, and I'm going to take 100 miles per hour, specifically because this will give us a really nice, easy number to deal with. And I would like to convert this to the units that we're going to use in the SI system, which is meters per second. And I'm going to do it a long way. In other words, I'm going to use only factors that I know and that I know are completely correct so that no matter how many sig figs I put in, I can get that many sig figs out. So what I'm going to do is let's go ahead and convert this to a fraction like I told you I'd normally do. So I'm going to write this as 100 miles per 1 hour, like that. Now, what I know is that 1 mile is equal to 5,280 feet. So I can do that, and then I can quickly look back and see that these miles cancels out with that miles, and now I have feet per hour. And then I know that 1 foot is equal to 12 inches. So now I can cancel out the feet. Notice I'm using a different slash mark each time. That's just a really good technique to keep yourself from making mistakes and to allow yourself to quickly find the mistakes. Now the next one, I'm going to go from inches to centimeters, and that's the key to this because this is a exact relationship, and that relationship is 1 inch is equal to 2.54 centimeters exactly. All these are exact in fact, but that one's a particularly neat one. Now we're up to centimeters per hour. So now I'm going to say that 100 centimeters is equal to 1 meter. And now I've used bottom left to top right and top left to bottom right. Now I'm just going to use an X. Okay, so now I'm up to meters per hour. Now I'm going to address the hour because I want it in meters per second. So what I'm going to do is say that 1 hour is equal to 60 minutes. And I'm going to say that 1 minute is equal to 60 seconds. And then that gives me it. Now, you'll notice I've got some cancellations to make out. So I've already used top left to bottom right, bottom left to top right, and X. So now I'm going to use bottom left to top right, only this time I'm going to use it as a curve. So I'm going to do like this and this. And then I'm going to do the same thing, but top left to bottom right for this guy. And you see that now all that's left, there's meters per second. And I'm going to go ahead and write the result right here. I know that I have 100 and I also have 1 down here. The units of miles, oh, I canceled out the wrong hour. That one should be canceled out, not this one over here. So now what I'm going to do is allow myself to take these numbers and multiply them all out so that I'll have the actual numbers. So right here, I'm putting the number 5,280 times 12 times 2.54 times 1 times 1 times 1. And that gives me 100 times 160,934. Notice how I'm keeping everything in little pods of 3. You should do that so it makes it easier for me to read. I would appreciate that. Now I've got to do the same thing. All I did was multiply all the numerators to get a new numerator. Now I'm going to multiply all the denominators to get a new denominator, and that includes 100 times 60 times 60. So 100 times 60 times 60 would be 36 with 4 zeros after it. So down here, I'm going to write 360,000. And of course, the units I have are meters and seconds. Now, the rule is you're just supposed to take the new numerator and divide it by the new denominator, and that is the number. But I wanted to show you what this factor is. So I'm going to take that 160,934.4 and divide it by the 360,000. Okay. So let's do divide it by that. And what I get is 100 over 1 times 0.44704. So that factor right there is really the key to converting meters per second or miles per hour to meters per second. So if I multiply that by 100, I get 44.704 meters per second. So that's the key. I actually only put in 3 sig figs. So the way we show that is I can underline this number and this number to show that they're not significant because I only put in 3 sig figs and I'm only multiplying. So multiplication and division gives you the same number of sig figs as you had. Uh, now, I will handle the rest of this, which includes dimensional analysis and unit analysis stuff next time. I would like to have put in the conversion for kilograms per cubic meter or grams per cubic centimeter. You can look up that example if you wanted to go ahead and start the extra credit, but the extra credit's there so you can do it. But next time I will cover it. We are done. Please, everybody, go ahead and chat me your first and last name. So type in your first name and your last name into the chat and then you guys are free to go. And I appreciate everybody coming. And I'm sorry I ran about 2 minutes over, but I think that's probably fine. We're not having any issues with it. And keep an eye out for my emails tomorrow. That's when I'll let you know when the other videos have been posted, including the video on the syllabus as well as the video on the next lab. I will be also, every Monday, Tuesday, Wednesday, and Thursday, I teach a class just like this. This is the Monday, Wednesday one. So I actually offer the end of this for office hours. You guys obviously are in class on Monday and Wednesday, but that means on Tuesdays and Thursdays, you could actually come in at 6:35 if you're able to and log into the Zoom meeting on Tuesdays and Thursdays, and that would be another office hour for you. So feel free to do that. And thanks for coming, and I'll wait for the last person to leave in case anybody has any questions.
Hi, I had a quick question.
Yes, ma'am.
Um, I was just wanting to double check how frequently was it again that you upload YouTube videos of the classes?
Okay, so there's a ton of videos already, And that's really all we technically have to do, but I'm going through and making new videos as the semester goes as well. My intent is to do a lecture video every Tuesday, Thursday, from basically like we did today. It would be in this class, it would be 5:20 to 6:40 on Monday and Wednesday, but I'm also doing another one for 2:42 from 5:20 to 6:40 on Tuesdays and Thursdays. And then I'm also doing one video a week, which I'll do at Tuesday on Tuesdays at noon for your lab.
Oh, okay. So you'll be making videos for every single thing that you just mentioned.
Exactly. Yes.
Okay.
Okay.
Um,
And there's, like I said, a ton of them in there. You'll notice when you go to my YouTube channel, I've got like thousands of hours of video, uh, but a lot of them are literally whole lectures from summertime. So, like classes that last 3.5 hours, you wouldn't want to watch a 3.5 hour lecture on physics, but you can. And what you do is just scroll through it until you get to an example that you're interested in, watch the example, and then fast forward again. Okay. But until then, you can use all those lectures. Plus, there's other ones that are just problems.
okay.
Okay.
Great. Thank you so much.
You're
Have a
welcome.
good
Have a good
night.
one, Brianna. So, just because I didn't have enough time to do the one I wanted to, I'm going to go ahead and put that on this video just in case anybody wants to get started and wants another example. So, I'm going to do the density of water, and I'm going to convert that uh, and show you how to do it. So, for instance, the density of water, rho H2O, is 1.00 grams per cubic centimeter. So that's the unit. What I'd like to do is convert that to kilograms per cubic meter, like that. Okay. So the way I'm going to do it is, again, I'm going to make this as 1.00 grams divided by 1.00 cubic centimeters. And remember, a cubic centimeter means a centimeter times a centimeter times a centimeter, right? So that's going to come in handy in a second. So first off, I want to go ahead and address the grams, converting that to kilograms. What I know from the mnemonic is that a kilogram is 10 to the third meters. So that's 1,000. So what I'll do is I'll say 1 kilogram is equal to 1,000 grams, like that. And now you can see that the gram has canceled out with the gram, and I now have kilograms per cubic centimeter. So it's obviously going to be a 0.001 kilograms per cubic centimeter. Now I need to deal with the centimeter, and we know that 1 centimeter, or 100 centimeters, is equal to 1 meter. And we know that because right here, if we look at the centimeter, that's 10 to the negative 2. So if I take that, what that means is 1 centimeter equals 10 to the negative 2 meters. Now, what I could do is multiply both sides by 10 to the 2. And 10 to the 2, like that. And when I do that, I end up getting 100 centimeters equals 1 meter. So that's the way I used it here. So 100 centimeters equals 1 meter. Now what I can do is realize, well, that's only going to take care of one of them. So I now need to do another one. That'd be 100 centimeters over 1 meter. And then there's a third one, so I have to put 100 centimeters over 1 meter. So the fact that that's third just means that has to appear 3 different times. So now what I get is this cancels out with this, and this because it's cubed. Okay, so we're going to divide by 1,000 because of the 1,000 in the bottom, but then we're going to multiply by 100 times 100 times 100. That whole 100 times 100 times 100 is 1,000,000. and dividing 1,000,000 by 1,000 to get 1,000. So the answer is, in fact, 1,000 kilograms per cubic meter. Now, we only started out with 3 sig figs, so I have to underline this, this, and this and say they're not sig figs, but that's how you do that. Okay, so if you look in the extra credit problem at the bottom of module one, you'll see there's a bunch of different units I would ask you to convert the density of water to. These are examples that I remember running into when I took my scuba diving class. If you've had scuba diving, you knew it before as well. I remembered like 64.0 kilograms per cubic meter, something like that, and another one was 62.4 for fresh water. So you can play around with those numbers till you get it. Another interesting unit is the ounces of mass per ounce of volume. So when they say, for instance, on a bottle, they say fluid ounces, that's a unit of volume. Whereas when they say ounces without the FL in front of it, that's a unit of mass. So you can actually find out what the density of water is in ounces per ounce, but it really means ounces per fluid ounce. And lo and behold, you'll be surprised what it turns out to be. So give that a try. And we're done. I will see you guys next time. Thanks for coming. Bye bye. Bye bye. Bye, everybody.